Good evening, everybody. Welcome to tonight's session on ways of studying the brain, part of your biopsychology topic. We're having a bit of a biopsych run, aren't we? Because I think we had a few last time, and then next week we're up with a toughie with lateralisation and localisation as well. We've not seen you for a while, so it's great to see so many of you in the chat already. We've been busy on our Grade Booster tour. We've still got some dates left to go, haven't we, Laura, in London?
Yeah, we do have a couple. We've got one at the end of April, one at the start of May as well.
Yeah, so you might be lucky if you want to just find yourself a last minute ticket. You can check out at tutor2u.net. Right, we're going to kick off straight away. We've got a little bit of teaching of the topic, haven't we, tonight? Because it is a notoriously tricky one. And then we're straight into some interactive sessions. So who's going to kick us off tonight, guys? We've got Laura and Melissa, by the way. Such a motor mouth. I just forget to introduce you guys. Who's kicking us off tonight?
Laura's starting tonight.
Laura, okay, Laura, whenever you are ready.
Great. Okay. Thank you, Laura. So we're just going to go through the specification first, just to give you a reminder of what's included in ways of studying the brain. The scanning techniques that you need to know about are fMRI, EEGs, ERPs, and lastly, post-mortem. So as Laura mentioned at the start, we're just going to go through a bit of teaching, a bit of a recap of each one of these scanning techniques before we get into our game. So if we go and start with fMRI scanning to begin with. So remember, this measures the blood flow in the brain when a person performs a task. Now, generally, fMRI images show activity approximately 1 to 4 seconds. Okay, and this is referring to temporal resolution. And it's thought to be accurate within 1 to 2 millimeters. That's our spatial resolution. I'm not going to go into too much detail on what those are because we're going to have a question on temporal and spatial resolution later in the session today. So really what this means is an increase in blood flow is a response to the need for more oxygen in that particular area of the brain when it becomes active, as that's shown in the fMRI scan, which suggests an increase in neural activity. So that's our fMRI scanning. Our EEG then, moving on. So this measures our electrical activity through electrodes that are attached to the scalp, and it measures brain waves. We're going to have a little session today on the 4 different types of brain waves later. So small electrical charges detected by the electrodes are graphed over a period of time. And again, that indicates the level of activity in the brain. So researchers are looking for 2 things when they're looking at the brain waves: the amplitude, which is the intensity, or if you like, the size of the activity, and then frequency, so the speed or the quantity of activity. Maybe a couple of areas there that maybe you need to note down and don't have that in your notes yet. So amplitude and frequency, okay, is what they're looking for in EEG electrical activity. So a very similar type of brain scanning technique, ERPs, again, they use very similar equipment to EEG. So again, we have our electrodes attached to the scalp, but this time a stimulus is presented to a participant. So that might be a picture or a sound, for example. And what the researcher will do then is they'll look for brain activity that relates to that stimulus. So really, the stimulus is presented many times, usually hundreds, and then an average is graphed. And obviously, the good thing about doing an average is it reduces the extraneous neural activity. And again, ERPs can also be divided into 2 categories. We have sensory ERPs, which are waves or activity that occur within the 100 milliseconds. And then we have our cognitive ERPs, which are waves that occur after the first 100 milliseconds. And again, that reflects the information processing of the stimulus. Okay, our last brain scanning technique then, we've got our post-mortem examinations. So this is the study of the physical brain of a person after death. Now, the reason why a researcher or a post-mortem would be carried out is because patients might have displayed a particular or perhaps unique behaviour while they were alive that suggested possible brain damage. So, for example, increased number of receptor sites on neurons. So like I said, we're going to have a look at a question now on temporal and spatial resolution. So what I'd like you guys to try and answer in the chat box this evening is explaining the difference. What is the difference between temporal resolution and spatial resolution? Now, you did have a bit of a clue in fMRI, and it's really good to know the difference between these two because they can be used as part of your evaluative material when you're evaluating the brain scanning techniques. So, what's the difference between temporal and spatial resolution? Excellent. So we've got Ava in there first. Temporal, we're saying, is frequency. Yeah. And Toby, well done. Yes, a spatial resolution refers to the level of detail in the location or area captured. Excellent. We've got lots of answers here. Now, just a question on the exam skill here. The question is asking for a difference. And one of the common mistakes, and we do cover it quite a bit in the Grade Booster course, is students often don't answer the requirement of the question in terms of difference. And what they end up doing is they end up explaining this is temporal resolution, this is spatial resolution. Can anybody tell me in the chat box, I'm sure some of you have already done it in your answers, can anybody tell me a word that we can use to demonstrate that we're giving a difference in the answer? What sort of connecting word can we use to show that we're giving a difference? Yep, so Johanna, well done. Whereas. And we really do need to make sure that we've got that. And, you can use in contrast as well. So let's have a look. Yeah, really good connective words coming along there. So we've got spatial resolution refers to the smallest measurement that a scanner can detect, whereas temporal resolution refers to how quickly the scanner can detect changes in brain activity. So really well done. You guys did really well in answering that question. Okay, going to pass you over to Mel now, and we're going to look at some comparative points for the scanning techniques.
Okay, fab, guys. So well done on some of these answers coming through for your definitions. Some of them were really, really high level at this stage, which is good at demonstrating that you are getting some revision doing. So we're going to have a little look at where we can compare these ways of investigating the brain. Now, it's a question you could get asked as a smaller mark, so, discuss a difference maybe, or we might want to use this as our evaluation within an essay or maybe a 6 or an 8 marker. So the first one we're going to look at how we can compare them is temporal resolution. And you guys have just had to go at defining that one. But I'm just intrigued, in these boxes, where might we put, what methods should we put under good temporal resolution, and which ones would we say have got poor temporal resolution? So I just want you to put in the chat box for me, which methods would we say have good temporal resolution, and which ones might we say have got poor temporal resolution? Okay, Grace has come through saying fMRI is poor. Well done. You got any others to come through? EEG is good. We've got good temporal resolution is EEG. Well done, guys. Some of you are super revised up on these. Yeah, so let's have a little look at the answers because it looks like some are really good ones are coming through now. Yeah, exactly that. So I think most of you, if not all of you, were completely correct on this question. Good temporal resolution, we can say the EEG and the ERP. And for poor temporal resolution, where we might see a bit of a delay in the screen versus when that activity is happening within the brain, we might talk about fMRIs. Now, as we said, if you're going to use this as a comparison point within an AO3 point or a comparison in general, then you do want to make sure you have that word whereas, and you would maybe want to provide a little bit more context behind. So does anyone know what the actual temporal resolution of an fMRI is? Can we expand a little bit further rather than just saying it's poor? Do we know how poor? How long does it take us to see that display maybe on the screen? Yes, lovely, excellent. Some good answers all came through at once there. So we've got 1 to 4 seconds, 1 to 5 seconds roughly. Yeah, exactly that. So if you are going to use this one as a comparison point, just make sure you put in your subject knowledge as well, rather than just this one has good and this one has poor temporal resolution. Okay, let's have a little look at where else we can compare them. So this time we're going to go for spatial resolution. Let's test our knowledge on this one. So which method has got good spatial resolution and which ones might have poor spatial resolution? Okay, we've got a couple coming through now. So we've got good fMRI, poor EEG and ERP. Yeah, lovely. Let's see the answers on this because it looks like most of you are going correct. Excellent. Easy way if you're struggling with revising at the moment and you feel like your brain is just so full, is just flip them on their head. So we've said that fMRI has got poor temporal resolution. But in contrast, it's got actually really good spatial resolution. We can see that activity happen right to the millimeter. Whereas the other two, which we said had good temporal resolution, have got poor spatial. So it's quite an easy way to remember them. Obviously, we can't bring post-mortem in here because they're not a live brain. We're not going to see that live activity necessarily with the temporal particularly. Okay, let's have a little look at the last one then. So what about this one? Invasive versus non-invasive. In other words, which ones are largely risk-free and which ones may be potentially invasive and cause some risk? Maybe a more difficult one. Okay, we've got a couple coming through. So I think we've got, Jago, you were first with post-mortems being invasive. We got a few people saying fMRIs are non-invasive. Exactly that, wonderful. So you can see the answers on the screen. So yeah, we could argue that post-mortems are arguably invasive. You know, we've got to really get inside the brain there and essentially slice it up. But not really an issue because that person is deceased. So as long as we've got some consent from that person or maybe a member of the family, then we're okay with that. Whereas actually a real strength of the other three is they're largely non-invasive. And you can compare it to maybe other methods that aren't on your spec. So PET scans, for example, they involve a lot of radiation, whereas these ones completely risk-free or largely risk-free anyway. So that could be another good comparison point you could make in your evaluation when you're thinking about whether they're invasive or non-invasive as methods. But well done. There were some lovely answers that you just put in the chat box. I'm going to pass you back over to Laura now for our suitcase scanner activity.
Thank you, Mel. Really good answers coming through, guys. So the suitcase scanner, what you're going to be seeing is you're going to be seeing some different graphical displays of some waves, and they're going to demonstrate the 4 basic EEG patterns, okay? So if we have a look at the first one is going to be showing where an individual is awake with mental activity. So what I want to know from you guys is, what's the name of this particular wave pattern? Okay, so what have we got answers? So I think we've got one right answer so far in the chat box. So again, some of you might not be well versed necessarily in these 4 types of EEG brain waves. It's I would say it's not directly quoted in the specification, but when you're giving outline or description and you're elaborating on EEG activity, it's good to know those 4 different types of brain waves that are measured via an EEG brain scanning technique. So we've got some mixed answers. Some of you are saying alpha, some of you have said beta. So the correct answer for this one is beta, because don't forget, beta waves are demonstrating when a person is awake but also aroused. Hence you can see the closeness of those waves together, okay? So high activity, if you like. Let's have a look at the next one, and then you'll probably be able to see a comparison here with an individual who's in deep sleep next, okay? So we want the brain name, the brain pattern wave of someone who's in a deep sleep next. Okay, so there are actually 2 waves that are demonstrated when someone's in sleep, but this one is particularly concerned with deep sleep. So I think we've got a correct answer here. I think Johanna, you've got it correct. Rach, India, Sarah, Leon, and Eve at the end there. Yes, so you are correct. We've got our delta wave there. So our delta wave, and there is another wave we're going to look at in a moment that is concerned with sleep. But delta wave is when we're in a very deep sleep. One thing I just forgot to mention with our beta wave, guys, obviously our beta wave is when we're awake and aroused, but this wave, this particular pattern that you saw on the screen, is also demonstrated when a person is in REM sleep as well, okay? All right, let's have a look at the next one then. Again, we're continuing on the theme of sleep. So again, the next one is demonstrating an individual who is asleep. So just asleep, not necessarily deep, but they've gone to sleep. What is the name of this brainwave here on the screen? Yeah, I think Johanna, you got in there first again. Annie and Rach following, India and Sarah, well done. Yes, so it's our theta wave, okay? So delta and theta waves are both demonstrating when an individual is asleep. We've got one more wave that we're going to show you on the screen. That's our fourth wave, okay? And this fourth wave here that we're going to show you is when an individual is awake, but as opposed to awake and aroused, they're awake and resting. So think back to the beta wave that you saw at the start, where the individual was awake and aroused. Now think this next one is going to be awake and resting. What is our fourth pattern here that we're looking at? Yeah, excellent. I think most of you have got that one. It's our fourth one, which is our alpha wave. Excellent. In terms of our rhythms at the end of biopsych, what would the sleep cycle be an example of in terms of our rhythms? Can anyone think? So think how long our sleep cycle goes on for. What sort of rhythm would that be demonstrating? Where could we bring this in if we were going to use it as an example in the rhythms? Yeah, if we were talking about the sleep and wake cycle, yes. If we were just talking about the sleep cycle specifically, then yeah, well done. A lot of you have put ultradian rhythm there. Yeah, so we'd use it for that. Okay, so less than 24 hours. Excellent. Well done. Perfect, guys. Really good answers. That was quite a tough one. Going to pass you over to Mel now for our next game.
So I'm going to take over this one, Laura, because we've lost Mel.
Oh, okay.
Yeah, she's with us in spirit, and I can see it on the screen, but I don't know what's happened. But shout out to Mel.
Okay.
So sticking with postmortems, as Laura and Melissa have been speaking about, we often use some detail in AO1 when you're describing them, but to be honest, in comparison to all the other methods spoken about tonight, there's not loads you can say. So terminology, structure of what you say really matters. And when it comes to evaluation, you need to be able to convince the examiner that you really know what's what. You haven't got things like temporal resolution and spatial resolution to rely on all the time. So here's a question for you. Bearing in mind that we always mention cause and effect, don't we, in psychology? Explain why causation is a limitation of postmortems. You may have heard the term bidirectionality. That's something that some teachers use for this point. But why can we basically not say that what we find in a postmortem is the cause of the behaviour? Why can't we establish that causation? If you think you've got an idea, pop it in the chat. So Annie said, it's hard to tell if brain damage caused the behaviour or resulted from it. Excellent, well done. And it would be really good if anyone can chuck in the chat an example. Because that point, Annie, is spot on. But for the game of the exam, we want a little bit more. Most teachers always want a little bit more in your evaluation, don't we? Paris says correlation doesn't equal causation. Fantastic, well done. That's not to say that we're going to draw correlations in a post-mortem. We might establish a cause and effect sentence. For example, we might say, if we're looking at the brain of someone who's been diagnosed with schizophrenia, and we do a post-mortem and we get stuck in there and we find loads more receptor sites than they should have on a postsynaptic neuron, we're going to say bingo, that's why they had schizophrenia. But actually, the treatment might be why they've got different receptor sites, lifestyle, drug taking, anything. So all those things that you've got in there, I can see lots of examples. They could be the cause of what we're seeing in a post-mortem. You're seeing the saying they may have had a brain injury, exactly. Brain lesions in epileptic patients, Natasha's saying, due to living with the condition. Fantastic. So some of these examples are great, and you could get a really good chunky paragraph if you just talk about how what we find in a post-mortem doesn't necessarily mean that this is why they're having an autopsy to begin with. So let's see if we can structure that in a bit of a clearer way. This is an example. You may write yours differently, but we've got all in there things that you've said. The problem is the thing that they're displaying in the lifetime, you've put examples in. I said schizophrenia. We've referred here to Broca's area. The deficits reported could have been the result of another illness, and we can't conclude or we can't establish cause and effect between the damage found in the brain and the deficit or the problem or the illness that the patient was experiencing anyway. So I get a bit excited about that point, don't I, Laura?
Yeah, there's some really good answers coming through there. I'm really impressed.
That's because I never get the microphone. I'm all giddy. I'm all excited.
Love
10-second countdown. Is this you or Melissa?
Melissa was going to do this one.
Okay. So, here's some quick fire games for you then. So, can you, in the chat, name a case study that can be used to demonstrate the contribution of post-mortem examinations? We've mentioned a few things in the chat already, but has anyone got an actual case study? We've mentioned Broca's area in that last slide as well. It's not necessarily a case study that you have to know, but if you're looking for something to use as evidence or a contribution, then there are a couple that you can use. Johanna said patient tan, fantastic, and that's what we've got. And I haven't set the 10-second countdown, have I?
You haven't, but that's all right.
T-minus 10 seconds.
I'll do it now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
There we go. Yeah, so we said this one, but there's some great ones. I can see some people screaming HM at me in the chat. Yeah, you're right. You've mentioned there about a schizophrenia study. There's absolutely loads, and some of you will be doing completely different optional topics in paper 3, and those topics are full of case studies of things like this. Brilliant, well done. Let's have a look at another one. So which way of investigating the brain is said to provide detailed anatomical and neurochemical aspects of the brain? 10 seconds. Pop your answer in the chat.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, some answers coming through. The correct answer is post-mortem, which a few of you have put. Some of you put fMRI, and I can kind of understand that, but when we're talking about really getting into the intricate details of the anatomical brain, which is basically the structure, an fMRI is going to scan it, but the one that's going to really get into those minutiae aspects of the anatomical physical brain, there's only going to be a post-mortem that does that. Everything else is finding other fancy ways to look at the brain. This is the hands-on. And I think that sentence there, the detailed anatomical neurochemical aspects of the brain, if we're wanting to strengthen that limited AO1 that we've got, then that's a good sentence to use. Okay, I think this is the last one for 10-second countdown. Which way of studying the brain can eliminate extraneous neural activity?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Well done. I think we had a full house there pretty much of ERPs. And that can be used as a strength for an ERP because an EEG doesn't do that. And that's one of your big differences between the two. So ERPs can eliminate all that extra noise that can sometimes affect those brain waves. Fantastic. Well done. I shall hand you back over to Laura to finish us to the end of the session.
Yep. I think we might have answered this one slightly with that last one. But let's see if we can all get an answer in the chat box this one. So you've got 30 seconds and I want a kind of full detailed answer. How are ERPs and EEG methods different? Off we go. Excellent. Some really good answers coming through. It's very easy, isn't it, with questions like this? You know, I forget how easy it is to fall into the trap of going, this is what an ERP does and this is what an EEG does. But again, it's just about answering that requirement of the question about the difference. And a lot of you put that, you know, ERPs involve a stimuli. You are correct, but then what's the difference with an EEG? We can't just say, okay, well, that doesn't. We've got to refer that to actually the brain activity that it's measuring. So I think, Rachel, you put ERPs focus on activity related to a stimulus, whereas EEG is just electrical activity and not a specific. So yeah, that's the key there. And I can see quite a few of you have said that that EEGs measure general brain activity and ERPs obviously record brain activity after a specific cognitive processing event, and that's obviously after a stimulus is presented. So yeah, really well done, guys, for your answers there. Some really good detailed ones as well. All right, suggest one area of biopsychology that utilizes EEGs to measure the brain. Yeah, good. I can see quite a lot of us have got the sleep answer. Yeah, we put sleep, but we also covered, what did we mention before in terms of our rhythms as well? So we can use it obviously as an example for our ultraradian rhythms at the end of biopsychology as well. But of course, that's not the only thing that EEGs can measure. A lot of you have put some other examples in as well, which are correct, but stages of sleep, because that goes hand in hand with those 4 brainwaves that we've looked at, and obviously links in with your rhythms at the end of biopsych as well. So our last game that we're going to play is Beat the Teacher this time. So we're going to give you a text. There are going to be 5 errors, 5 deliberate mistakes in the text, okay? And the text is about 2 brain scanning techniques, and that's all I'm going to tell you. So what I'm going to ask, guys, is for you to read the text, and then I would like you to pop into the chat box when you think you've got the 5 errors, if you just enter them all in at the same time. So let's reveal the text. So I'll give it a read. So the key difference between EEGs and fMRI is that a stimulus is presented to a participant. The researcher looks for activity related to that stimulus. The stimulus is present one time and an average response is graphed. This procedure, which is called averaging, reduces any extraneous neural activity, which makes the specific response to the stimulus stand out. The time or interval between the presentation of the stimulus and the response is referred to as latency. ERPs have a very long latency and can be divided into 2 broad categories. Waves that occur outside 100 milliseconds following the presentation of a stimulus are referred to as sensory ERPs, as they reflect a sensory response to the stimulus. ERPs that occur within 100 milliseconds are referred to as cognitive ERPs, as they demonstrate some information processing. So what answers have we got? It's definitely, obviously, 5 mistakes there. So can anyone spot the first mistake? I think you've all got is ERPs, it should be instead of fMRI. Well done. Let you guys have another read through and see if you can spot the next few errors there in the text. Yeah, so there's a bit of a muddle when we're talking about the waves that occur. We've got outside 100 milliseconds. It should be inside the first 100 milliseconds. I think, Annie, that's what you were referring to, and a couple of others there, Annie Jack. So we've got outside 100 milliseconds, and obviously that means that our ERPs that occur within should be outside 100 milliseconds. So well done for noticing those 2 at the end there. We've got 2 in the middle still that we're looking for. So let's reveal the answers for this one then, because I can't see if anyone's picked up that second and third one there. I'm sorry if you have and I've missed it. So we've got the stimulus is present one time. Well, that's incorrect. It's present many times, okay? Usually hundreds, as it says there in brackets, was the big giveaway. Excellent. Well done, Paris. Sorry, I missed that. You said one time. And then with our third mistake there, we've got ERPs have a very long, we should have short latency. It can be divided into two broad categories there, okay, as your key differences there between EEGs and ERPs. Very easy to kind of get those muddled sometimes because they sound very similar, but they're very different in a lot of ways there. So well done, guys. You've done really well answering those questions this evening on quite a tricky topic in biopsychology for brain scanning techniques.
Oh, there she is. You're back. Can we hear you?
Yeah, you should be. Can you hear me?
Yeah.
We've got you back. Right.
Always the way, isn't it? Halfway through.
Great session, lots of good answers, lots of people in tonight and really good quality answers, and those that didn't always get them right, you gave it a great effort, so that's all we can ask at this point. And it's going to be cheesy, isn't it, if I say get things wrong, it's a learning curve, and then you just don't get it wrong again.
True, though. It's true.
It is very true. Right then, fantastic. Don't forget you can watch this again if you want to, on demand on our YouTube channel. You can also get more information from us about these sessions and more at our Instagram at Tutor2Psych. And we're back next week, 6 o'clock, Tuesday the 8th, with localization and lateralization. Do not let that put you off. It's very much an area that everyone could do with a little bit of extra help with. So we will see you then. Thank you, Laura and Melissa, and we'll see you everybody next week.
Well done, guys. Thank you.
Thank you.
Bye-bye.
Bye.